Now introducing Dr. Samuel Neely and Dr. Ethan Hicks and friends in calculus class.
Hello everybody. Today we're going to be learning about derivatives.
Woo! Yeah! Ready to learn!
And we're going to learn about antiderivatives.
Oh, hell yeah! Woo!
The first lesson in this calculus course is on derivatives. Does anyone not understand what this is? Now, a derivative can help you find one specific thing: the slope at a certain point on a graph. So here's my example. You have a graph like this and you want to know the slope at this point right here. Well, if you find the derivative, that can help you know the exact slope of at that point. So say you want to find the slope at this point, which is f of 2. What you have to do, if the equation, let's say for an example, is 3x squared plus 4x minus 2, you take the derivative. How you do this is you bring down the exponent of this first coefficient and you multiply it. So you get 6x, and you got to remember to minus 1 from this. So it's just going to be 6x. Then what you do from this is, since there's an invisible 1, you bring it down and multiply the 4 times the 1, and you get plus 4. Now since there's no variable on this 2x, it actually just comes out to a 0. And so what you have now is you have the equation f prime of 2 is equal to 6x plus 4, and this is going to give us the slope at the point x equals 2. And what you do now is you plug in that value into the x, and you'll be able to find the slope. So I plug it in, and it's 6 times 2 plus 4, and we find that the slope at this point is 12 plus 4, which equals 16. That's the slope at our point right here. That's the first fundamental step of finding the derivative and how it applies to this graph.
Woo! Yeah! Nicely done!
Thank you.
Wow!
So now that we've covered the derivative, which I taught about, my good friend and Dr. Ethan Hicks is going to teach us about integrals. Ethan, what do you have to say about that?
Thank you, Dr. Sam. Thank
Woo!
you, thank you class for having me.
Woo!
So today, the second thing we're going to learn about is the integral or antiderivative. So basically an integral, what it does is, if you have a certain equation, like Dr. Sam had previously, of 3x squared plus 4x minus 2, I can find the area underneath the curve of this graph in between two distinct points. For example, with my graph over here, I can find the integral to 2 underneath the curve and find this area right here. So basically you start off with using your integral symbol and having distinct points to use. And remember, if we don't have a definite integral, we have to add a plus c at the end, which is just adding a constant at the end. So to do the antiderivative of an equation, you do basically the opposite of finding the derivative. Question?
Sir, wasn't there an x in that equation?
Yes, there was, right here. Thank you. So, keep going. You basically do the opposite of the derivative. Instead of minusing 1, you add 1. So I add 1 to each exponent. So 1 plus 1. And so, once I have my new exponent, I divide by that new one. So instead of being 3x squared, it's going to be x cubed, because I divided the 3 into this 3 right here. For the 4x, I added 1 to the 1, so it's going to be 2x squared. And for the 2, it's just going to be added 1 divided by 1, it's going to be minus 2x. And that's your equation for an antiderivative. But you have to find the area underneath two distinct points. So now we're finding the area underneath the curve from 0 to 2. So basically you do f of b minus f of a, which is the equation of finding an antiderivative. And you get that 2 is b and 0 is a. So you plug in the 2, you get 2 cubed, which is 8, plus 2x squared, which is 8 also, minus 4. All that, which would equal 12. And then 12 minus, if you plug in the 0 for each x, it's just 0. So that the area underneath the curve of 3x squared plus 4x minus 2 on the integral of 0 to 2 is 12.
Well done, Ethan. Why don't we give him a round of applause? So guys, now that you've learned these two very fundamental things about calculus, how do you feel about it?
I feel so good I can teach it.
Me too.
Yeah! Woo! Go into the world and let them know on your education.
You got it.
What am I saying?
Calculus.
Hey, what's up, guys? Nothing like some calculus, am I right? Woo! Calculus!
All the ultimate kids.
Calculus, baby! Hey, nothing like some frisbee and calculus, am I right?
Calculate that trajectory.
Hey, hell yeah, my man! Woo! Round 2! I cannot get enough of calculus! Woo! Woo!
Hey Dalton, did you know for calculus, to get the antiderivative, you add 1 to the exponent and then divide by the new exponent?
Is this a question?
No, I'm telling you.
I'm telling you.
You just know.
Are you retarded?
Thanks, Dalton.
Woo! Calculus!
Hold in.
Wait, what should I do?
What's your opinion on calculus?
You know, today it was really an eye-opening experience. Really made me, hey, how you doing? It really made me appreciate, you know, calculus as a whole, especially in the derivative and antiderivative aspects. How do you feel, Tyler?
I think it was great. It furthered my education. Dr. Ethan Hicks and, well, Sam. He's a
Back to Holden.
Yeah, that was enough out of you, Tyler. I just really think that with this newfound knowledge, who knows? I could be the next Joe Johnson.